In this lesson, we are going to go over graphing parabolas, part 2. So our objectives are we will understand standard form of a quadratic function. From that, we'll be able to determine the vertex, axis of symmetry, and maximum or minimum value of the function. Then we'll also apply our previous knowledge of intervals of increasing and decreasing and domain and range to quadratic functions and be able to determine those from the information that we have. Okay, so remember, standard form of a quadratic function is f of x is equal to ax squared plus bx plus c, and of course a cannot be 0 or else we don't have our x squared term. Definition, so the vertex is the lowest or the highest point of the parabola. The axis of symmetry is the vertical line that goes through the vertex, and we'll see this in our next couple of examples visually. Okay. So use the graph of the quadratic function to find the following. So first the vertex, the axis of symmetry, the minimum or maximum value, where the function is increasing, decreasing, domain, and range. Okay, so first let's start with the vertex. So this is our vertex. It's our lowest point of the parabola in this case, and this is located at -1, 2. Oops. The axis of symmetry. So the axis of symmetry, remember, is the vertical line that goes through the vertex. It's also, if you were to fold the graph along that line, each side would coincide. So visually, here's what it looks like. The axis of symmetry, okay? And notice it cuts the parabola right in half. What's on the right side is mirrored to what's on the left side. And this is a line. So remember that the axis of symmetry is a line. It's a vertical line. X equals -1. This has a minimum, and the minimum value is the y value of the vertex. Okay, so that is 2. So I'm going to write this here. This is -1, 2. Okay, so the function is increasing. So here is where the function is increasing. It's always open. So our x-coordinate is -1, and this goes all the way to infinity. So from x -1 to x infinity, this graph keeps going up and up and up. Okay, it's decreasing, so it starts away back here and continues on until x is -1. So this is -infinity to -1. Okay, the domain, there's no restrictions on this. This is going to keep going, so we're going to have really big negative values and really big positive values. Our domain here is -infinity to infinity, and the range of the function is the lowest y to the highest y value. So the lowest y value occurs here, again at the vertex at 2. There is a point there, so it gets a bracket, and then we have y values going all the way up to infinity. Next example, use the graph of the quadratic function to find the vertex, the axis of symmetry, and the minimum or maximum values of the function, and we're also going to throw in increasing, decreasing, domain, and range just to get more practice with that. So here is my vertex. In this case, since the parabola is opening downward, it is the highest point. Okay, and this is at 3, 0. The x-coordinate is 3, 1, 2, 3, and the y-coordinate is 0. Okay, so this is 3, 0. The axis of symmetry is the vertical line that goes through the vertex, and this is the vertical line with the equation x equals 3. In this case, the function has a maximum, okay, and the maximum, did I circle? Okay, I did. The maximum is 0. The function is increasing, okay, from -infinity to 3. So it's our x values that cover where y is increasing. So this is -infinity to 3, and it's decreasing from 3 to infinity. Okay, the domain, again, there's no restrictions on this. Pretend that this keeps going on forever and ever and ever. We're going to have -infinity to infinity, and my range is the lowest y value to the highest y value. Okay, in this case, the lowest y value is -infinity, and the highest y value is 3, and there's a point there. It's included. It gets a bracket. Okay, so those are some visuals of what we're going to be talking about, but we can get some of these too from the equation. Okay, so properties of standard form. So again, we have f of x is equal to ax squared plus bx plus c. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. This is another way of saying if the number in front of x squared is positive, it opens up. If it's negative, it opens down. The vertex is an ordered pair given by x. The x-coordinate of the vertex is -b/2a. Okay, and once we find x, we substitute that in, or we input that into the function to get the y-coordinate of the vertex. And the axis of symmetry is the line, x is negative b over 2a. So notice, in our previous examples, or what we talked about is it's the vertical line that goes through the vertex. So notice that our vertex was 3, 0, and the equation of the axis of symmetry of the line was x equals 3. Okay, so it is, the line is equal to the x coordinate of the vertex. So that's why you see the negative b over 2a there again. Okay, maximum or minimum, again, if the graph opens upward, the y coordinate of the vertex is the minimum value. If the graph opens downward, okay, so upward, here's our minimum. If it opens downward, here's our vertex. The y coordinate of the vertex is the maximum value. So let's go through some examples. So use the following function. F of x is equal to x squared plus 4x plus 3 to determine the following. So with the vertex, the first thing that we do is we find the x coordinate of the vertex. Okay, and it's given by that formula, and it's also on your sheet of negative b over 2a. Okay, so in our function, a is equal to 1, b is equal to 4, c is equal to 3. So negative b, which is negative 4 over 2 times 1, this gives me negative 4 over 2, which is negative 2. Okay, now once we find that, we need to find the y coordinate, which is given by f of negative 2. Okay, and that's where you saw negative b over 2a. So you find x, and then you put it, the x coordinate in the vertex, and then you substitute it in, or you input it into the function to find the y coordinate of the vertex. Okay, so this means that negative 2 is going in for every x. And now we evaluate. So this is 4 minus 8 plus 3, which is negative 4 plus 3, which will give us negative 1. Okay, so and our final answer here for the vertex is negative 2 comma negative 1. Okay, the axis of symmetry, remember the axis of symmetry is the vertical line that goes through the vertex. It's x is equal to negative 2. Okay, the parabola opens since a is positive 1. This is going to open upward. Okay, so part D. So we have the same function. We're just evaluating different things here. So since the function opens upward, we have a minimum value. And it's the y coordinate of the vertex. So that's negative 1. Okay, and now increasing, decreasing domain and range. So something that's helpful is you might be able to see it just from putting together the vertex and how this parabola is opening. But something I find helpful is I like to visualize. So here's my vertex, negative 2, negative 1. It opens upward. Okay, and the exact image of it doesn't matter for finding increasing, decreasing domain and range. So my function is increasing from negative 2 to infinity. Okay, so it's increasing negative 2 to infinity. And it's decreasing from negative infinity to negative 2. Okay, this graph is going to keep going on forever and ever and ever. My domain here is negative infinity to infinity. Okay, it's usually that way for a parabola unless you've got endpoints that are stopping the graph. Okay? And the range is the lowest y value to the highest y value. So the lowest y value is negative 1, and it goes all the way up to infinity. Okay? In the homework problems, you are asked to graph these, and so what you'll do is, this is a parabola, so you select the graph that looks like this. When you go to graph it, you plot the vertex. So in this case, we'll plot negative 2, negative 1. And you only have to plot one other point, but make sure that point is within the bounds of the graph. So the x values go from negative 10 to 10, and so do the y values. So in this case, you might have to evaluate another value of this function. So I would maybe find f of 0. So that would be 0 squared plus 4 times 0 plus 3, which would give us 3. So this is the point 0, 3. Okay, so you would do 1, 2, 3. And once you plot those 2 points, MyLab will make the parabola. Okay, so I just wanted to go over that with you. Example 2, use the following function. F of x is equal to negative x squared minus 6x minus 11 to determine the following. So we're going to find the same things as we did in example 1. So the vertex, the x coordinate, is given by negative b over 2a. My a in this case is negative 1, b is negative 6, and c is negative 11. Okay. So negative b, so there's still a negative, or you can think of it as opposite of b with that negative in front. over 2 times negative 1, which gives me 6 over negative 2. So my x-coordinate is negative 3. Now to find the corresponding y-coordinate, I need to use that as the input. I need to find f of negative 3. Okay? So f of negative 3 is equal to, so there's a negative in front. And then I put negative 3 in for x, minus 6 times negative 3 minus 11. Okay, so there's a negative in front. Negative 3 squared is 9. This becomes plus 18 minus 11. Okay, and then we keep going. So we have negative 9 plus 7, which is negative 2. So my vertex has the coordinate negative 3 comma negative 2. Okay. The axis of symmetry is x is negative b over 2a, or remember it as the x-coordinate of the vertex. X is negative 3. Okay. And the parabola opens, since a is negative, this is going to open downward. Next, do we have a minimum or maximum? Well, since it opens downward, we are going to have a maximum, and the maximum is the y-coordinate of the vertex, negative 2. And then we have increasing, decreasing domain and range. So just as a rough sketch, 1, 2, 3, and my parabola opens downward. Okay, so it's increasing. Oh, let me write this here. Negative 3, negative 2. So it's increasing from negative infinity to negative 3. Okay, and then that means it's decreasing from negative 3 to infinity. My domain is negative infinity to infinity, and my range is my lowest y value to my highest y value. Again, graphing the function. So in this case, you would select the same parabola tool because the graph of a quadratic function is a parabola. You would plot the vertex. Okay, and then you would plot one other point. And in this case, you have to be careful what that one other point is. For instance, if you were to plug in 0 into here, we would get y is negative 11, and that's going to go off the graph. So something that you could plug in is like negative 1. So if you found f of negative 1, this is negative 1 squared minus 6 times negative 1 minus 11. So we've got negative 1 plus 6 minus 11, which is negative 1 minus 5, which is negative 6. Okay, so the other point you could plot would be like negative 1, negative 6. And once you plot both of those two, it'll make the rest of the graph for you. Okay. Example 3, use the function f of x is equal to x squared plus 5x plus 6 to determine the following. Same things as examples 1 and 2. So the vertex is given by x is equal to negative b over 2a. A is 1, b is 5, c is 6. Okay, so in this case, it's going to be negative 5 over 2 times 1, which is negative 5 over 2. It can be a fraction. Okay, so now I have to substitute this in, find the y-coordinate. So I input it in for every x. Okay, so I get negative 5 over 2 squared means negative 5 over 2 times negative 5 over 2, which is 25 over 4. 5 times negative 5 over 2 is negative 25 over 2. And then I have plus 6. Now in order to add these, I need common denominators. So my least common denominator here is 4. Okay. So this can stay as 25 over 4. If I need to multiply the bottom by 2, I also multiply the top by 2. 6 is over 1. I need to multiply the bottom by 4, so I multiply the top by 4. Okay. And so now we have 25 minus 50 plus 24 over 4, which if we simplify, 25 minus 50 is negative 25 plus 24, so negative 1/4. Okay, so my vertex here is negative 5 over 2, comma negative 1/4. And it's okay to have fractions there. The axis of symmetry is x is negative b over 2a, so it's the same as the x-coordinate of the vertex. And since a is positive, this opens upward. So again, we have the same function, and we're determining, so if it opens upward, we have a minimum value, and the minimum value is the y-coordinate, okay, of the vertex. And then we can visualize this one as well, negative 5 over 2, negative 1/4, so that's something like this, and it opens upward. Okay, and this is negative 5 over 2, comma negative 1/4. So my function is increasing from -5/2 to infinity. It's decreasing on -infinity to -5/2. My domain is still -infinity to infinity. Okay, and the range is the lowest y value to the highest. So -1/4, infinity. Okay. And I'm going through those increasing, decreasing domain and range because those are topics that we've been talking about. But if you need help with them, please do let me know. Example 4 is an application problem. So the function c of x is equal to 0.78678x squared minus 27.752x plus 387.360 models how the energy expenditure of parakeets depends on their flight speed, where c represents calories burned and x represents speed in miles per hour. How fast should a parakeet fly to minimize calories burned? Round your answer to 2 decimal places. Okay, so we've got a graph. It's going to be some type of parabola. Okay. We're trying to minimize calories burned. So we're looking at a minimum value, and it's asking how fast should the parakeet fly. So what this is really asking for is the x-coordinate of the vertex, because the x-coordinate of the vertex is where the minimum happens. Okay. So we have x is equal to -b/2a, where we have -b, or opposite of b, over 2 times 0.678. Okay. It's also, when the question is asking how fast and we're told that x represents speed in miles per hour, we're looking for an x value. Okay, and since it's saying minimize, we're talking about the minimum value of this, or where that occurs. Okay, so if we plug this into our calculator, where's my calculator? Okay, and I get 20.4660, ... We're rounding to 2 decimal places, which means we're rounding the second decimal place. Okay, so we underline the 6, we look next door. The number next to it is 5 or greater, so that 6 goes up 1, and this is in miles per hour. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.